Welcome to this video on percentage yield and atom economy. In your exam, you could be asked to calculate the atom economy of a particular reaction and may also be asked to calculate percentage yield of a reaction. So think of percentage yield as basically a way of determining how close the actual yield of a reaction is to the predicted or theoretical yield. A formula you can use is actual yield divided by theoretical yield multiplied by 100. So here's a question for you to try. A sample of 2-chloropentane was made treating 10 centimeters cubed of pentan 2O and an excess of sodium chloride and concentrated sulfuric acid. 5 centimeters of 2-chloropentane was produced. And the reaction is as follows. The densities are listed here, and the question is calculate the percentage yield. So the first step to solving this question is firstly converting these volumes into masses using our mass equals density times volume equation. Now we have the mass of pentan 2O and a mass of 2-chloropentane. Now this is the actual yield, because 5 centimeters cubed of 2-chloropentane was produced. Now what we have to do is calculate the moles of pentan 2O, as this can then allow us to calculate the theoretical moles of 2-chloropentane. The molecular mass of pentan 2O is 88, and we get an answer of 0.0927 moles. Now, looking at this equation, we can see that there is a 1-to-1 ratio between 2-chloropentane and pentan 2O. Hence, we can assume that the moles of 2-chloropentane is also 0.0927. Now, since we know the moles of 2-chloropentane theoretical, we can calculate the theoretical mass by doing moles times the MR So our moles multiplied by the molecular mass of 2-chloropentane, which is 106.5, and we get an answer of 9.8725. Now this is our theoretical yield. Now all we have to do is sub it into the equation. And we get a percentage yield of 44%. So, first step was to calculate the actual mass of 2-chloropentane using mass equals density times volume. Then we calculate the moles of pentan 2O, and there was a 1-to-1 ratio, so the moles of 2-chloropentane was also the same. Then we calculate the theoretical mass of 2-chloropentane by multiplying it by the molecular mass of 2-chloropentane. And we got that. And then we simply substituted it into our formula and we got an answer of 44%. Now, atom economy is basically the success of a process, or a percentage of how much the reactants get converted into useful products. And the question must specify what is the useful product. And a formula you can use to calculate atom economy is mass of useful product divided by total mass of reactants multiplied by 100. Now, when it says total mass, you can actually use molecular mass in this example. So look at this question. It's the same equation, and it says calculate the atomic economy of making 2-chloropentane. So what we have to do in this is, well, we know our useful product is going to be 2-chloropentane. So we work out the molecular mass of 2-chloropentane. Then we have to work out the masses of all our reagents. So the mass of pentan-2-ol, sodium chloride, and sulfuric acid. And we get that the masses are 88 plus 58 plus 98 equals 244. Now we can solve this into the equation to get atom economy of 43.6%. So then, just to summarize, what is percentage yield? Well, it's actual yield over theoretical yield multiplied by 100. And in this question, we had to calculate our actual yield using the information provided, such as the density, and then we had to calculate the theoretical yield using our moles of pentan-2-ol. Atom economy is basically the success of a process, and it's a percentage of how much of the reagents get converted into useful products. And you can use molecular mass when working out atom economy.